nothing better to do on a Thursday evening. You can watch this. Statistics, and like I said, some of these questions you've seen before. Some of these and this particular set, the file that you have is all the questions on statistics from, I guess it goes up to 2016, 2014, 2021. So you get an idea of the style, the type of questions that may show up in a couple of weeks. Okay, so a lot of these are common sense. Okay, so I don't think you should have any problems. Where are we? School principal wants to determine the type of speaker the students prefer to invite to an assembly for an entire student population. Which survey method would produce the best representative sample? And I guess the keyword is best and representative, right? We want to represent the population. So survey every fifth person shops at a mall. Survey all the students on the student council. Not good either. Survey every student entering the school one morning. Every 10 students, I'm sorry. And survey all the students. So again, there's a little bias here, right? People at the mall have nothing to do with the school, so this is gone. Survey all the students on the student council. Well, I mean, the students on the students council, I don't think they represent the whole school, right? So they also is gone. Survey every student entering the school one morning. That looks a little bit more representative of the entire population. It's not biased. And survey all the students who went to the last basketball game. No, because then you get only people who like basketball. So C is the best answer. 2, a 7th grade ELA class teacher wants to order books for all the 7th grade classes. He wants to determine the favorite type of book. Which sample? Who should he ask for this? 7 girls in each of his classes? No, because he's only getting the opinion of girls. Every 5th student in the 7th grade. That seems okay. 1 out of every 7 students in his middle school? No, because he teaches 7th grade, so no interest in asking 6th graders or 8th graders. And all the boys in one of his 7th grade classes? Absolutely not. So the only one, and again, common sense here would tell you that it would be this guy, right? Middle school principal wants to change the lunch menu. The principal surveyed the students to determine how the students would feel about changes. Which survey method will best produce the best representative sample? Every 5th student who rides in a car to school? No, right? Because, I don't know, it could be biased. I mean, if you have a car, I don't know, it biases a certain type of, I guess, economic status, maybe, right? Survey 3 randomly selected students from every homeroom. That's not a bad one. Survey every 10th grade student during lunch. That's not a bad one either. Survey 5 randomly selected students from every art, drama, and music class. That's a no, because not everybody takes this, or this. So this one is gone. A and D are gone. Then obviously the best one would be this, because it's from every homeroom, right? Because you want to produce the best representative sample, and if you're taking 3 kids from every homeroom, it would represent the whole population, as opposed to every 7th grade student only. We're ignoring the 6th and the 8th. All right, so that would be thirsty. Letitia randomly selected 25% of the 7th graders in her school and asked them their favorite season. Of the students surveyed, 51 chose summer as their favorite season. Based on the data, what is the most reasonable prediction of the number of 7th graders in her school who would choose summer as their favorite season? So 25% of the students surveyed, 51 chose summer as their favorite season. Based on the data, what is the most reasonable prediction of the number of 7th grade students in her school? Hang on a second. Let's see what this would be. Give me a moment. Hmm. Hang on a second. It's not giving me a total. It's 25% of the 7th grade students. Of the student survey, 51 chose summer as their favorite city based on what is the most convenient position. But I don't know what 51 is out of the 25%. Am I reading this wrong? I'll come back to this one. I'm going to look for the answer for this one because it says 25%. So the problem I'm having here is that, let's divide. Right, so she asked this group of people, right, 25%, and 51 kids here, but I don't know what 25% is. 25%, I don't know how many kids that represents, because a school could have 1,000 people, right? If the school had 1,000 people, that means that 25% is 250 kids. There's 250 kids here, and 51 of those kids, 51 kids here at 250 said summer was their favorite season. So I don't know how to answer this because I don't have that number. Am I reading this wrong? Select 25%. The student survey, 51 chose summer as their favorite season. What? All right. Come back to this, or if you have the answer to this, let me know. Mario sells men's and women's shoes in his store. He's considering selling children's shoes. This would be shoes. He's considering selling shoes, children's shoes. He randomly selected 120 customers to participate in the survey. The survey's results are shown below. 42 said they would shop for children's shoes. 78 customers say they would not shop for children's shoes. Mario has an average of 440 customers per month based on those surveys, which value is the best estimate of the number of customers that would shop. So let's add these two. 10 carry 1. We got 8. 1. So he asked 120 people. And at 120 people, 42 said they would buy children's shoes. So based on those results, let's multiply that by 440, and we should get a number here. So I have a calculator. 42 over 120 times 440. 154. So B is the answer. Okay. This one is bothering me. I'll come back to that. 3, to select a new mascot. 20 randomly selected students in each grade were asked to choose the finalists, tiger or eagle. The results are shown. So in 5th grade, 14 chose tiger and 6 chose eagle, and so forth. Which statement is best supported by the results? The preferred mascot is a tiger. Let's add this up first of all. So 14 plus 13 plus 8 plus 5 equals 40. So we had 40 over here. 40 people chose tiger. And 6 plus 7 plus 12 plus 15 equals 40. So that's a tie. So that's not true. The preferred mascot is an eagle. Not true again. 5th and 6th graders at the school prefer an eagle. Well, 5th and 6th graders said there were 13. And obviously there's more tigers. So that's not it. So D is the only available choice. 7th and 8th grader students at the school prefer an eagle mascot. Is that true? Well, 12 plus 15 is 27. 8 plus 5 is 13. So in the 7th and 8th grade, the eagle was the more popular one. Scores of 10 random selected students based on the medians. Well, please, it's not in order. What inference would you make about the quiz? Scores of all the students in Class A compared to all the students in Class B. Explain and justify your answer. Okay, median. To the median, we have to put them in order. So let's do A over here and B over here. 60, 65, 70, 70, so 2 70s. 75, 80, 80, 80, and then 85, 90, 90. So the median right? So if you go from here, we have 1, 2, 3, 4, 5, and you have 1, 2, 3, 4, 5. So the median is right here. So 75 plus 80, add them up, divide by 2. You got 77.5. So the median for class A is 77.5. The median for class B, what's the lowest? 80? Is there an 80? No. Is there an 85? Yeah. 185, 285, 385. 1, 2, 3. Oops, there's a 75 there too. 75 and then 85 3 times. And then we have 90, 1, 2, 3, 4 times. 1, 2, 3, 4 times. Then 95, then 100. Okay, so the median here would be this number, right? And the median would be 90. So class A's median is higher than class B median is higher than class A. Explain your reasoning to justify your answer. Well, we found a median, so class B is greater than class A. Is there anything else we can talk about here? You can talk about the range, right? The range for class B is only 25, where the range for class A is 30, right? So the grades in class B are not widespread. If you want to talk about MAD, I think the MAD in class B would be definitely lower, right? The variability, sorry, forget what I just said about the MAD. They're asking about the median. But you can talk about those too, right? Class B median is higher. The range is lower, so that puts that group, right? The median score, it looks like more people did better on class B than class A. 5. So this might be a similar question. I think we even saw it on a test. Survey, museum's employee. He asked 350 people. Of those 350, 266 stopped at the gift shop. Based on those results, how many people out of 2,300 would you expect to visit the gift shop? So 266 out of 350 visited the gift shop. So if you had 2,300, how many of those would visit the gift shop? Well, 266 divided by 350, then multiply that by 2,300, and it should be 1,748. And again, you saw this question on your test. 6, teacher survey about doing classwork online or paper. Based on the results, how many students out of 350 will most likely prefer to do their classwork online? All right. So first of all, find a total. There were 25 people asked, and online, 17 out of 25 said, I'd rather do it online. So if you had 350, how many kids would that be? So 17 divided by 25 times 350, that'd be 238. Okay. What is this? Line plot. What is this? Quiz scores from her first period class, second period class. She gave the same quiz. What conclusion can we get from this? Let's see. The first period class had a higher median. That's not true. If you look at the median for this class, even if you don't put all the numbers in order, the median, the number in the middle would be around here. The number in the middle for class B would be, I'd say, 7, right? So A is gone. The second class period scores had a higher mean than the first period score. Yeah, if you add those up and divide it by however many kids, I think the mean would definitely be higher. It's, you can tell. C, the first period class scores had a greater range. Well, the range for class A was 6 minus 2, which is 4. And the range for class B is 10 minus 5, sorry, 9 minus 5, which is 4. So the range is the same. So this is not true, that's not true. So far, B. And the second period class scores had a greater mean absolute deviation than the first. Well, does this class here had a bigger MAD? Are those numbers? So if 7 is the mean, let's say 7 is the mean, right? See how all these numbers are very close to 7, right? So I think the MAD here would be, well, be just very, very, where do you go? Just the same as the MAD in class A. Because the MAD in class A, they're not, look, all these numbers are not too far from 4, and all these numbers are not too far from 7, so they're about the same. So the only one that's really definitive is that the average score for second period class is definitely greater than the average score in class A. That would be B. All right. There's a sign. The line plot shows the speeds of the motorists before and after the sign. Okay, before the sign, you had drivers who, I don't think they would care too much about the speed. They were a little bit careless, and you had a guy driving at 40, 38, right? Now, once that sign was installed, is there anybody driving over the limit or at a big speed of 40? No. So the mean speed and the range of speed of the motorist decreased. So the range for here is 40 minus 20, right? So it's 20, highest minus lowest. The range from here is 35 minus 20, which is 15. So the range definitely decreased. The average speed decrease? I'm going to say yes, right? I think the average, if you add all those up and divide by however, the average looked like it decreased. So this looks good. The median speed and the range of the speed of the motorist increased. That's not true at all. It decreased. The mean speed of the motorist decreased. True. The average speed decreased. And the range increased. Well, that's not true, so that's gone. The median speed of the motorist increased, and the range of the speeds decreased. Well, the range definitely decreased. The median increased? No. And again, if you wanted to quickly verify, you could do the median. And I'll do the median just to confirm. So let's do the median for the bottom one. It's 20, 22, 25 4 times. 1, 2, 3, 4, and then a 28, and then 33 times, and 35 twice. So the median would be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and the median is the number between 25 and 28, which is 26.5. So the median after the sign was 26.5. Let's see what the median was before. So it's 20, 24, 25 4 times, and then 30 twice, and then 35 twice, and then we had a 38 and a 40. 1, 2, 3, 4, 5. I'm just working towards the middle. 1, 2, 3, 4, 5. And then the number is 27.5, the number in the middle, right? Between 25 and 30. Did the median increase? No, the median decrease. So the only one that really makes sense is A. Here's the bowling scores, and again, we'll do this next week. So, but you get an idea. So, I mean, the one thing I've mentioned before is that box plot here divides your data into quartiles, right? So each of this divided into 4 parts. So that's 25% of your data. That's 25%, and that's 25. And likewise, that's 25. That's 25%. That's 25%. And that's 25%. Right? The scores on Fridays and the scores on Saturday have the same median an interquartile range. That's not true. So the median, the number in the middle is right here for Friday, and the number in the middle is here for Saturday. Are they the same? No. So that's gone. The scores on Friday have a greater median. Yes, right, the median. And a greater interquartile range than the score on Saturday. So the interquartile range is the size of the box. If you think about the size of the box, they're about the same. This one is also gone. The score, I mean, they're about the same. I'm visually doing it. I'm taking the lazy way out. But if you look at this box right here, right, and you took this value and you subtract from this value, and you took this value, subtract this value, it looks very similar. Right? We can count, right? So it's 1, 2, 3, 4, and this is also 1, 2, 3, 4. So they're exactly the same. The scores on Fridays have a greater interquartile range. So the moment they say the interquartile range is one is greater than the other, you know it's already not true. So just by default, D is the answer. The scores on Friday have a greater median. True, right? Number in the middle, this line right here. But both data have the same interquartile range. Yeah, so D is the answer. All right, again, I think you saw this on a test, or we've done it on the review sheet. Bus drivers and teachers and how far they live from school. The interquartile range for the bus driver is twice the interquartile range of the distance for the teacher. So is this box twice the size of this box? The bus driver? No, it's not. So A is gone. The range of the distance for teachers is twice the range of the distance for the bus driver. That's not true. The range for the teachers, 35 minus 5, which is 30. What's the range for the bus drivers? 30 minus 5, which is 25. Is it double? No, it's not. Garbage. The interquartile range of the distance for the bus drivers, right, this box here, is 5 less than the interquartile range for the distance for the teacher. So is this box here 5 less than this box here? It looks like it, doesn't it? Because here it's 20 minus 10, which is 10, and here it's 30 minus 15, which is 15. So the box for the teacher is 15 more than the bus drivers, right? So this is the correct one. Malika and Adrian prepare containers of potato salad. Each container was supposed to have the mass of 1 pound. Okay. Manage to select a random sample of containers prepared by each employee to check the mass of each container. The results are shown in the table below. So you're supposed to give customers 1 pound. Well, Malika, sometimes to one customer she gave 1.10, the other customer she got 1.08, the other customer she gave 1.05, one customer got a little bit less than 1 pound, and another customer got a little bit less, again, by 1 pound. Adrian, on the other hand, my God, you don't want to be served by this guy, right? You're supposed to get 1 pound, so you either get a lot more than 1 pound or quite less than 1 pound. So Malika will produce more containers with a mass of exactly 1 pound than Adrian will. Yes, but I have an issue with exactly, right? Adrian will produce more containers with a mass of exactly 1 pound than Malika did. No, Adrian is definitely too inconsistent, so that's gone. Most of Malika's containers will have a mass closer to 1 pound. Now that's what you want, right? That makes more sense. So most of these containers will be closer to what you wanted or asked for, which is 1 pound. That looks really good. Most of Adrian's container will have a mass closer. So Adrian is garbage. So it's either A or C, but because the word of exactly here, Malika will produce more containers with a mass of exactly. Not true, but she will produce containers with a mass closer to 1 pound. So C is the only one that really makes sense. What the heck is this? Surveyed employees from each of the 4 different companies about their daily commutes. The table shows the commute times for the surveyed employees. Company 1, took 24 minutes, 26, 28, 23, 21. Company 2, 6 minutes, 32 minutes. Nice. So some people live close to the company, some people don't. Company 3, everybody took 15 minutes. I don't know. Maybe they all live in the same building. Company 4, one person really lives really far, who's 45 minutes away, and everybody else lives in the vicinity. Based on the data, which company most likely has the longest average commute time? So which one has longest average? So if you were to add this up, who has the highest average? So the average is going to be, well, so all you got to do is add them, right? Add them and divide by 5. So if this would be 15. I'm going to say this guy, right? So company 1, 2, or 3. Well, let's just add them, right? 24 plus 26 plus 28 plus 23 plus 21, enter, divided by 5. This is around 24.4. Next one, 6 plus 32, 6 plus 32 plus 9 plus 31 plus 21, enter, divided by 5. This one is 19.8. Okay, wrong. So that one's 15, and the last one, 13 plus 10 plus 45 plus 12 plus 15, divided by 5, 19. So this one, has the average. So company 1. Right. 3, last question. This is so short. Coach, compare the heights of the players of 2 different teams. The data set is shown in the table below. Okay. The mean height of the players of Team B is greater than the mean height. So you actually have to add this up. You can't just eyeball it. 76 plus 68 plus 73 plus 65 plus 60 plus 63 plus 69 plus 76. Enter. Divided by 1, 2, 3, 4, 5, 6, 7, 8. This one here is 68.75. And the bottom one, 63 plus 73 plus 64 plus 70 plus 70 plus 67 plus 75 plus 62. Enter, divided by 8 again, 68. The mean height of mean height of the player of Team B is greater than Team A. True. So A is good. The mean height on Team A is greater than the mean height on the players of Team B. Sorry, hang on a second. I didn't read this correctly. Team B is greater than Team A. Not true. A is not it. Team A is greater than Team B. Yes, the average, yes. The median height of Team B is greater than the median height. So B is already true. Do we have to do the other ones? I guess for the sake of doing it. So let's put them in order. Team A, I'll do it over here. 60, 63, 65, 68, 69, 73, 76, 76. So the mean is the number in the middle, so it would be right here between, so 68.5. What does it say? The median height on T, oh, I got to do the bottom one. The bottom one we have 62, 63, 64, 67, and then 70 twice, and then 73 and 75. The number in the middle is between 67 divided that by 2, and we get 68.5. It's the same. So the median, so C and D is garbage because the median is the same. So the correct answer is B. All right, that was a short one, but it counts as 2 days. So good.